In this clip, I'll show you like another example that is like near real world. I can say that this one is a near real world and very popular data set. This was used in the world of the research before, and you can find many data sets in the very popular website relating to the players that uh, we can read, we can find many ideas, how can we work with the data, and of course, a lot of data sets. But this data is originally in the UCI. This is the repository of the machine learning data. This one is a lot of them are the data that used in the research. Um, the idea of this data set is this one is the data set of iris that will be classified into three classes. There are three classes that are uh, the iris setosa, iris versicolor, and iris virginica, and there are four attributes. That is the sepal length, sepal width, and petal length and petal width. These four attributes. Okay, so you can download the data from here. You can see that a lot of paper that cite this data set. So we can go to the data folder, and then there is the file called the iris data. You can copy the link here, and then we will download this file into um, our notebook. So in this case, I will start working with iris data. So and then we have to download it first. To download a file from the internet, we use the BlueGet, and this one will be the file called the data. So once you run it, it will be downloaded to your VM. And after you finish, I would like to introduce you another very important library in the data science. That is the pandas. The pandas that we use is the actually you can do a lot of things with them, but to make it easier, I've used this part, just only the part that we read the data and send it to our learner. So to use it, you have to use import panda as PD. That after this point, we will call it as the PD. To read the file, at first you have to know that what is the data in this file. So the idea is you can use the Unix commands that more the iris.data. This one is the Unix command iris data, and once you run it, you can see that here there are nothing just four attributes and the class. Okay, and it will have more and wait for your input. So I type Q to quit. So now you can see that we have iris.data and the content is like this. So the idea is it is a CSV file, that is a normal text file, and each data is in one line, and in the data it's separated by a comma. So you can read it in the data frame called df. This is the data frame that is the CLF, the classifier that many people use that name to store the model from sklearn. But for the data frame, many people also they use df. So we use df is pd.read csv. This is the statement. This is a function that you can read the data. It is the you can provide a file name iris.data, and because this file has no header, can you see? No header. The first line is the data exactly. So you have to provide that. Header is none in this case, because you have to tell your data frame that okay, we have no headers. once you run it, your data will be stored in the variable df, and you can check the values of df by typing df in another cell, or you can put it in the last line of any cell. If you put it in the last line of any cell, it will show the values of this variable. So now you can see that we have like four attributes, right, and one class here, and there are 150 rows. So now I will name it. I'll name it. Put the name to the columns of this data frame. So guys, let's go back to your UCI here, and you can see that there are four attributes, that is sepal length, sepal width, and petal length and petal width. These are the column names, that so you can put it here, sepal width, and then sepal length. Sepal length first, and then sepal width, and then petal length, and the last one is petal width. Okay, so and the last one is the class. Once you name it, and I'll put the variable df here as the last line of this cell. So you see here we have the columns already. Okay, so guys, now we have to send it these values from here. You can see we have four attributes, right? So because we have four attributes here, I think it's much better if I use this one. This one, we have four attributes as the input vector, right? And we have the last one, that is the class of the data. So guys, how can we use this data and replace it in this cell, right? Because x is the input and y is the class. So I'll copy this one. Actually, we don't need to import them anymore because we already imported, but we can keep it here, because sometimes you may want to run like get the data and run it, start from this part. So maybe you want to run just only for the iris one. So if you want to run using this cell, only this section, so there's no imported statement yet. So I import it again here, and then to use the data, because now we must use the first four columns here, right? We must use the first four columns as the x1. The way that you can select the data, the first four columns, is this is the way that you can select the first column, petal length. Okay, so this one is the way that you can use the columns name. Oh, sorry, there's one in centimeter here, so I'd like to remove it. So now we have first four columns: sepal length, sepal width, and petal length and petal width. So we can choose just only one columns, and this one I will introduce a little bit relating to the Pandas concept. I think that you can see that we have five columns, right? And each columns, we call it the data series. And once everything are combined, this one is the data frames. So the data frames contains many data series. So you can select just only one series like this. This one is the series of the petal length. Can you see? And you can choose more than one series, like put it like select just only two of them. For example, you want petal length and petal width. You can put the name of the series into a list and provide it here inside a square bracket, and then it will show you two series here, right? And you can see that we have two series and the index. This column is the index, so we have two series. We have two series here because you select two series here, right? You provide a list of two columns names, that is petal length and petal width. So our example is in the first four columns. So I will put the list of the column here: sepal length, sepal width, petal length, and petal width. Once you enter, oh sorry, I missed the last closing single quote. So now we have the data like this. So you can see that now we have the one data that is the input vector, right? And this one is another data, and we put it together like a matrix already. So you can use it as the x1. This one will be the data from pandas. So x will be this set of the data of this data frame. Four columns or four series will be gathered here as the input vectors. And because we have many input vectors, so it called input matrix. And for y, we use the last one, that is the class. Okay, so you can see in many examples in real world, they use it like the lowercase letter. I'll explain a little bit more about this. If we use x, it means that we have many vectors. So x will be the matrix. This one is one vector, right? And this one is another vector. But if we combine all vectors together, it will be a matrix. So many people use the x variable. Okay, and because in the last columns it is just only a series, so this one is like a list of many values. I hope that you can still remember what is the data here, right? So for the last line, for the last line, it is the class. So if you use this series, what does it mean? It means that you are using a list of iris settles, iris virginica, and iris versicolor. This one is a list of the class, so it is just only a list. So you can think that this one is just a vector. So many people use the lowercase y to represent the vector and the uppercase to represent the matrix. Okay, so but it depends on you. It's okay. If you use store x and y in these variables, we can change it now. Okay, so you can copy the values of x and y here also and place it here, and then delete this one. And once you run it, guys, what happened? Sorry. I'm very sorry that I put it in the wrong feature names. That the feature names must be 4 of them. Okay. And the class name, guys, this is a trick. that for the class name, it will be sorted. If it is a string, it will be sorted as in the dictionary. So you have to provide it like iris setosa, iris virginica, and iris versicolor. So the first one is iris setosa because S is the first character here, right? Iris setosa. So the class name will be iris setosa first, and then uh, iris virginica and iris versicolor. So you can check the name of these uh, class by using this one is the df.class, and you can use .unique, and it is already sorted, right? Okay. So the class name will be iris setosa, iris versicolor, and iris virginica. So that's all. So you can copy this name and place it here. So iris setosa, iris versicolor, and iris virginica. So once you run it, oh, I'm sorry that we still use the y from the previous experiment. So we have to change it to this y. Now you can run it, and then you can see that now we have already the class. In the first part, we have the petal width less than 0.8. If it's less than 0.8, and if it's true, we can classify it as the iris setosa. So all of them is like you have 50 of them, right? So it's totally correct. Okay, for the whole examples in this leaf node, they are the iris setosa. So you can move next to iris versicolor and iris virginica. For the part that is not finished yet, that there are like 50 and 50. So the class that will be classified in this node, if it's not, because actually it's not the leaf node, so we don't use this node to classify the example yet. So we have to follow the link. If petal length is less than 1.95, 1.75 here, so you have go here to this root. So the values will be 0, this one, 0, 49, and 5. This is the iris versicolor. Okay, so it use use other like other threshold to divide them into like many leaf. So you can see that here there are many leaves, and some of them like you may think that I think many people think that I think it's enough because it is iris virginica for sure. That's just only like the iris versicolor, just only one here. So if you want the tree to be smaller, we prefer the smaller one, because if it is like too complicated, guys, this one, if your trees look like just only this part, I think we can refer to the version space that if your rules or if your condition is like relaxed or you don't have many constraints, your rules will be general, and this is good for us to use this tree in the like for the unseen example. Okay, so guys, we have the tree. So this tree is like a little bit bigger in my opinion. Okay, so we can make it smaller using the pruning techniques that provide in your decision tree classifier. You can set some parameter here, this one. We have like the max depth, that is to limit the depth. Min sample, guys, min sample leaf. You can read in the description that the min sample leaf, sorry, we have max depth, we have min sample split, okay, and min sample leaf. The min sample split is the minimum number of the sample required to split an internal node. It means that if you use this one, if you use this number, it is the like the minimum of the sample in the node. The default is 2. Okay, so it means that the min sample split is 2. Okay. If the number is less than this, you won't split anymore. Okay, so for example, if I change it to like min sample split to be for example 5. So if the look please take a look at your tree. We have some nodes that the min values is like 3 here, right? Can you see we have a node here that is there are just 3 nodes. So if you don't want to split them, you have to set this one and then try to run it, and we can see, okay, sorry, oh, min samples, oh sorry, min sample split is 5. So if this node, from comparing to the previous version, this node has 3 and 3, so they won't be split anymore, right? Because you set it to be 5, but this node is 6, right? So the number of examples here in this node is 6, so this one will be split. Okay, so if you want to make it like, okay, I don't want to make it to be like split the node if the number of nodes in the leaf is 10. So now your tree will be like smaller. Okay, so this is the way that like we use it to limit the growth of the tree. And you can set something like you have min sample split, right? And then we have min sample leaf. This is the minimum numbers of the sample required to be at the leaf node. It means that, so if you set these values, this is default is 1, right? So the default one, it means that so any number will be accepted. So if you set that you don't want the leaf to be less than 5, for example, so you can set min number leaves to 5, and this is the sample. So in your leaf, can you see in your leaf node, all of them must have the number of examples in these leaf node must be greater than 5. So this is the way that we can like limit the growth of our example, our tree. And we have I have one parameter that you can use. It called min impurity decrease, because I think you can imagine that we try to reduce the entropy or the impurity of the nodes. So the values of impurity must be decreased. If the number is like decreased less than these values, we won't create a new leaf, or we won't create a new node. So for example, if we set it to be like 0.05, this is the result of your tree. Can you see? It can limit the, like, if the, like, the number of the values of impurity decrease less than 0.05, we won't create the leaf node anymore. Okay, so I hope that you can get the idea of how can you fine tune your tree using these parameters. Okay, this is like one of the near real world example using all continuous attributes. I'll show you in the next video clips that how can we use the data in our example, that once when we learn the theory, we use the class, right? We use the like the label of the data, like the temperature is high, lower, or the outlook is sunny and rainy and overcast. So how can we change that values into the number? Because in sklearn it accepts only the number. So in the next video clip, I'll show you how can we do it.